Hello and welcome to another Monday night Q&A. I'm joined tonight by my colleague Craig Hawkins, one of our area engineers and assessors. Good evening, Craig.
Good evening, Sam. How are you?
I'm good. How's your Monday been so far?
Been a busy, eventful, pleasant Monday. Been a good day.
Good. Yeah, no, it's always nice to have a good Monday. Sets you up for the rest of the week. So, as with all of our live Q&As, we'll just run through a few house rules, in particular for those that maybe haven't joined us on a Monday night before. So we start off with the question of the week, which we posted out across social media channels earlier today. We'll go through our answer to that question together with the rationale behind that answer so it becomes clear, hopefully. And then while you're putting questions into tonight's live chat, we'll go through some of the questions we didn't get around to asking from previous sessions. So please put your questions in the chat. Remembering one of our golden rules is that there's no such thing as a stupid question, only stupid answers. So please don't be afraid of asking anything that you've always wanted to ask. Remember to be respectful to each other in the chat, as the whole idea of this evening is really to collectively help each other with the overall aim of improving our collective knowledge of all things BS 7671 and a better understanding of the world of electrical installations. So without any further ado, let's have a look at what this week's question of the week was. So earlier today we posted out the question, which of the following should not be used as an earth electrode? And the options that we gave were A, structural metalwork, B, lead sheath of cables, C, water utility pipe work, or D, earth tapes. So from that list, which one of those should we not be using as an earth electrode, Craig?
So chapter 54, specifically 542, section 542, does talk about this, and the answer here is C. So 542.2.2 gives a list of earth electrodes that are acceptable. So the normal ones, earth rods and pipes. Occasionally we might see earth tapes and wires. We might see an earth plate. Item 4 is underground structural metalwork embedded in the foundation or other metalwork installed in the foundation, so that would be classed as a structural metalwork part of it, so that is included. And then the one below that is lead sheath of cable, then it's not precluded, so lead sheath is not precluded on that one. So as we can see there, A, B and D are acceptable, and it's actually C that's not acceptable. There are some other items of equipment or metallic parts that are not suitable for an earth electrode. So 542.2.6, a metallic pipe or gases or flammable liquids should not be used, and the metallic pipe of a water utility supply should not be used as an earth electrode. It does say other metallic water supply pipe work should not be used as an earth electrode unless precautions are taken against its removal and it's been considered for such use.
Yeah, and that's really the reason why we don't want to use it, isn't it? Because although it may be metallic and it may be conductive, it could change. It's not owned by the property owner, and therefore that water utility pipe work could be changed by the utility owner, and that would then remove their connection to earth. So that's really one of the reasons why we can't use it, because it wasn't it, in if we go back 30-40 years, it was quite common for it to be used. But then we started to see the great rollout of non-conductive polythene pipe works, and therefore we would absolutely lose that true connection to earth.
And we see it quite often, a lot of water pipes that have burst or slight damage on them. The quick and easiest way to rectify that is to replace it with a non-conductive pipework that is less likely to corrode and deteriorate as quickly as a metallic pipework does. So, as you said, sir, as soon as that gets removed and replaced, your reference point to earth and your protective measure is out the window.
Yeah. Yeah, no, and that's then why we can't, because we can't rely on it for future durability. Okay, so please put your questions in the chat. Are we talking EICR code questions? Yeah, we'll try and have a go. Certainly, we'll try and answer anything if we can. If we can't, we'll let you know. So while you're doing that, we'll just have a look at some of the previous questions. We did want to have a quick look back at last week's question of the week as well. So last week's question of the week was around who should make the recommendation for the interval for the first periodic inspection and test of a new installation. And we noticed last week that a lot of people were going for the responsibility for defining that first periodic inspection. They were putting it down to the inspector or tester, so the person involved in completing the inspection and test required for initial verification. But that's not actually the case. So who should it be? You know, it is clear in 7671.
It's the designer of the installation. So when we have the first initial inspection and test, or the first initial putting into service, and then the interval for the next condition report, or the first condition report, the installer or the inspector or the tester doesn't have an understanding of the utilisation, the people using it, and the intended use of that electrical installation, whereas the designer of the installation should have all that information collated for them, and they have a much better idea of what the installation is likely to be used for, what level of deterioration, what level of maintenance that installation is going to go under within that time period. So it's the designer of that installation that holds that information, and therefore can make a justified decision as to the interval between its first installation point and when it is then had its first condition report.
Yeah, absolutely. And I think sometimes people feel that because the inspector or tester is the last person, if you like, to touch the installation as part of the whole project, they should be the ones that decide how long till the next inspection. But the reality is, on a new installation, that should be in pristine condition at the end of that inspection and test, and should therefore be designed to last as long as the designer has designed it against. So that's really where it comes from. Although the inspector and tester might be the last person from the electrical contracting firm or the business who are responsible for supplying the installation, it will be the designer, as you say, because they may have had the conversation with the customer about how long does the customer want it to last, and therefore, you know, what do they need to design, bringing into mind how often is it going to be maintained. So all of those things will be discussed with the designer, not necessarily with the inspector and tester, so they won't have that knowledge to make that engineering judgment of when it should be first inspected.
I would like to make clear as well here, if it's okay, Sam, is that there are some businesses where the designer, the inspector, and the tester is all the same person. So, but the hat that you have on at that point in time is that of the designer. So although when you go and install it, you're the installer and you inspect it and you're inspector, but when you have that conversation with the customer and understanding the intended use, you are the designer. So I see where that question can get a little bit confusing for people that have got small businesses or they're on their own, that they are acting in all of those duties. But in actuality, if you transpose that into a larger business, then you have a separate designer who would be, you know, or might not be part of the business, might be a third party, and then you might have the electrical firm that's installing that. And don't forget, we don't actually see the clients a lot of the time with big projects like that, where we look at this design. We might not ever meet the client or the person that's going to use the installation, so we might be putting equipment in that we don't know what's going on the end of it. We might put an isolator in ready for a piece of machinery, or we might put a socket outlet in for a piece of equipment that we don't know what's going on the end of it, because the design has been provided to us by a third party.
Yeah, no, it's a really good point, isn't it? Because I think we sometimes get so used to being the single person, like you say, that does the single signature on an installation certificate, but we always have to be mindful that it is quite common, especially on larger projects, to have one organisation or one body of people doing the design, one doing the install, and then a third doing the inspection and test. And as you say, they could be from completely different organisations. So okay, another one question that's been hanging around from previous ones is if on a single circuit it's made up of a number of different cable types or conductor sizes, due for example to allow for volt drop or connection methods, should the distribution board schedule and the schedule of test results record all of the cable types and sizes used in the circuit? And I guess that question is, we've got limited space, haven't we? So we've got a very limited amount of space. So what can we do in those situations where we've actually got multiple cable types and multiple cable sizes used on the same circuit?
So the beauty of the model forms in 7671 now is that we have a lovely big box that says notes, that we can actually record it on the installation certificate in those aspects of that as well. And it's handy for anybody that's reviewing those certifications at a later point, maybe for a condition report, and understanding the actual installation practices that were apparent at the point of installation. We see this quite often. Part of my previous career, I worked in the street lighting industry, and those length of cables are significant, 1-2 kilometre long lengths of cable, which are 125 mil 5-core armoured, but the street light itself will not accept that. You might try, but it won't fit. But you might have a much smaller cable size that actually enters the street furniture itself, so you have a smaller cable size for that. But the only reason we have that length of cable is, as Sam said, is for the volt drop of those circuits, because they're quite significantly long. But yeah, there might be different reference methods for those ones. It could be that the main armoured might be in a concrete trough, and then the actual SWAs that feed the street furniture might be in some underground ducting. So we have a couple of different reference methods there, and we also have a different cable, although the types are the same, but the cable size would be different. But really handy to put that onto the notes section of the installation certificate to let anyone else know the actual installation that they have in front of them.
Yeah, and so rather than try and squeeze information into a small space, why not use that space to reference where the information could be, and then as you say, use a separate page, a note page, to actually record that information, which will then be relevant to the next person that comes along. Okay, we'll take one more and then we'll start to scan through the chat box. So again, a common question that comes into the helpline: can a minor work certificate be used for replacing a circuit breaker for an RCBO? So that's one example, but in general, if we're replacing a protective device for a protective device which has different characteristics, then yes, that would need to be certificated, because that's seen as an alteration. So first of all, yes, it would need certification, because it differs from, we're not doing a like for like replacement, we're actually changing something, changing the protective device's characteristics. So yes, we could use a minor works, that would be acceptable for that. Because it's only a single protective device, and it would be considered an alteration to an existing circuit. You could, if you had lots to do, use an installation certificate. It would be a little bit of an overkill for something that small, but that's another alternative. But yeah, it's a great example of where a minor work certificate could be used, and then it would also enable the designer and installer to document exactly what was done, so i.e. which protective device was changed in which distribution board or consumer unit, record the results of any relevant inspection and testing, and also the minor works will let you comment on any issues that you see with the existing installation. So that really does tick all those three boxes. Anything you'd add to that, Chris? Craig?
Yes, so Appendix 6, which is the model forms for the model forms in 77.1, there has been a change in that in the Second Amendment, and we can see that by the little lines, the black lines in the margin on the right-hand side. And one of those changes for an installation certificate is that instead of issuing multiple minor works, then actually an installation certificate can be used in lieu of multiple minor works, because if you've got, I don't know, 100 RCBOs, or you change from circuit breakers to RCBOs in an installation, 100 minor works is going to take a bit of time. So a way of achieving that for the intent of that form, you could actually issue an installation certificate for that. But a one-off occurrence of minor works would be required because you are changing the characteristics of that protected device. You're altering an existing installation or circuit, and we want to make sure that that degree of safety is no less safe than prior to us attending.
Okay, so we'll start to pick up some questions that are coming into the chat, so thank you very much for those. So first one that jumps out is on an EICR, no earth on the lighting, laminate floor everywhere, so there's an emoji. Can you still have all class 2 equipment and the white plastic pips in screw holes? So first thing to say is, if there's no earth on a lighting circuit, which again was common sort of in the 60s, not to put run an earth onto a lighting circuit. So providing all of the accessible equipment is class 2, then you could still record that as on an EICR as a C3, a recommended improvement, but due to the fact that the class 2 accessories will mean that you've removed the possibility of electric shock through there, you'd still be able to record it as satisfactory with a C3 recommendation to add an earth. Just picking up one thing about the white plastic pips on the screw holes, this again is something that comes up a lot. There is actually a regulation that says if your potential metallic parts are too small to be gripped or to come into contact, significant contact, then you don't need to earth them, and it does give the example of fixings, bolts and screws that fall into that. So if we have got a plastic accessory, plastic switch plate, even though the metallic screws might be visible and could come into contact, because they're not seen as large enough. I think the dimension given is 50mm by 50mm, has to be larger than that in order for considerable contact to be made or gripped, and then it would need to be earthed. But if it's smaller than that, it doesn't need to be. Anything you'd add to that, Craig? I'll just try and pull up the reg number for that.
It's the page before the ADS page. I can't give it the page number. No, I would like to add is that we do get fixated on ADS as the protective measure that we tend to employ, and that is probably the most common protective measure that we have in the electrical safety world. But there are other measures. So the measure that we're referring to here, where everything is class 2 and there isn't an earth there, and we can't touch anything metallic, is double insulation. It's a protective measure that prevents us receiving electric shock, because you have to break down 2 layers of protection before we can get to something that is a live conductor. And fault protection only is actually there for singular faults, not multiple faults. So double insulation is another protective measure. Other ones include SELV, PELV, earth-free potential bonding, and shaver sockets. So electrical separation is another form of protective measure. So although we have ADS as our main form, we do have other forms of protective measure, and one of them being that we would implement in that regard on an over installation is actually double reinforced insulation.
Yeah, and that regulation, for the engineer that asked that question, I was looking at, it's on
410.2 from memory.
410.3.9 on page 63. Have a look at that, because that gives a great example of where fault protection can be omitted, and that's a great example of that. one question or comment that's come in, I guess it's related to the question that we had about the interval for the first inspection. Somebody said, would guidance note 3 interval not apply? Yeah, that's guidance, so you can use that as the designer. You don't have to, because you may know additional information. You know, that the most probably pertinent one would be maintenance regimes, preventative maintenance that takes place, and so you might want to extend it. But yeah, you can, by all means, you can use the guidance which is in both guidance note 3 and also in the NICIC test and inspect guide as well. So they're good steers for general installation types. Got one here about I've got a ZS of 1.32 ohms on a ring circuit with a B32 amp breaker. Will this be a C2 using the 80% rule? Okay, so off the top of my head, it's the only one I always remember. B32 amp breaker's got a maximum ZS 1.37 at 100% value. So yeah, you would be above the 80% value there. Now the thing would be, why are you above the 80% value, and also does it also have RCD protection, being a socket outlet, because you've said it's on a ring circuit. So if it has got RCD protection, then it wouldn't be, because you can rely on the RCD for your fault protection and your protection against electric shock. In which case then 1.32 ohms is well within the range of a typical 30 milliamp RCD. So that would be one thing. Also, I think you want to look at why, you know, 1.32, it's not an awful lot, much more. Is there a loose connection somewhere that you could tighten to make sure that you've brought it back down? Have you got any information of what that value was before, how long ago since it was tested? So are you seeing deterioration? But yeah, a little bit more investigation as to why. But yeah, if there's an RCD protecting the socket outlet, then it wouldn't be a C2. If there's not, and you are relying on that C2 and it is above the 80% value, then yes, it would be recommended as a C2. But I would say it's one of those ones where it does seem a little bit harsh without having investigated further. So perhaps try to ensure that you've not got any loose connections on that ring circuit.
Another thing to look at there is that the 80% rule is a informative appendices attached to 7671, and it's in relation to the conductors getting warmer when they're under load. So depending on the load of that circuit under which point you've taken the test, would indicate whether or not that 80% value is that value that you've got there is a true within the 80% and not so. So that particular 80% in the appendices does say that if you've got circuits where your loading of that circuit is not going to exceed or get close to the current carrying capacity of the conductor, it is safe to say that the cable isn't going to get any warmer than it would under those load conditions, and therefore the 80% rule actually doesn't apply in every case. So I know I'm going to mention street lighting again. 125mm cable going a kilometre down the road isn't going to get warm when it's got 15 to 20 amps running through it. So the 80% rule there wouldn't necessarily have to apply, because my cable's not going to get warm to the point that it's going to increase the resistance of the cable through the heat induced in the increasing resistance for the copper.
Yeah, thank you. Okay, a question that's come in from another engineer. So, are you obliged to upgrade the main equipotential bonds if you're fitting a like-for-like fan in a bathroom, if undersized or there isn't any in place? So two questions really there, and we'll have to take those separately. And same question, but if you are installing the wiring from a local circuit. So I think the few things that run through my mind with that question is that strictly speaking, like for like replacements of accessories aren't actually covered by 7671. It falls outside the scope of 7671. However, if we are looking at somewhere where there isn't any bonding in place, if it's required, then we would always suggest that should be done. I'm thinking about, you did say it was a bathroom, so we should also, if there isn't any supplementary bonding required, then there should be RCD protection for the circuits in that bathroom. So those should be in place. The main question about, in general, if for example we've got 6mm bonds, but we note that it's a TNCS earthing system where the minimum should be 10mm, then our advice is, so long as there's no evidence of thermal damage to the 6mm bonds and we're not actually adding any load, in which case if there were perhaps some circulating currents in the bonding conductors, we might increase them. But the fact that we're not adding a load, then you wouldn't need to upgrade the 6mm ones if they were deemed adequate, i.e. not showing any signs of thermal damage, and maybe even confirmed through measurement that there's no circulating currents flowing in the bonding conductors. But yeah, if there's no bonds and they're required because you can simultaneously access conductive parts, for example, then we would recommend that the bonding's done before any additions or alterations are carried out. If you say the same question but you're installing the wiring from a new for a new local circuit, then you would need to put any bonding requirements in meet the current regulations. So that would mean again that if there's new bonding required, that bonding would need to be at 10mm or minimum of 10mm if you've got a TNCS system. So yeah, a few different questions in one there, but I think we've answered them. If not, please come back and let us know the specific one that you were particularly after. The new 18th edition schedule of inspections on an EICR asks us to check the tightness of conductors. This contravenes the Electricity at Work Reg 14, that shall not work next to live conductors. So I'm not sure about that, because the EICR doesn't ask us to check the tightness of conductors when they're live. So in an older property, how can we check this without removing the main fuse, albeit the neutral is still not isolated on the tails? If we if we're talking about the tightening of the tails, the incoming tails, then yeah, obviously, although we may be able to isolate the installation through, for example, the main switch in the consumer unit or first distribution board, then that won't actually isolate the energy on those incoming tails. So yeah, perhaps I understand now where you're coming from in that not working on live conductors, because yes, we wouldn't be expecting people to remove that. But my understanding now that it was made clear on the latest EICR that the distributor's equipment on that side is a visual inspection. So I think that's a case of we wouldn't need to have verified that through measurement or torqued screwdrivers. We can just make a visual inspection of that equipment on the supply side of the installation, and then make an overall comment that the responsible person asking you to do the EICR may have to report back to the distribution network operator or building network operator if it's a large building with distributed supplies, but it shouldn't affect the outcome of the condition report of the installation. Anything you'd add to that one, Craig?
Well, Appendix 14 puts onus on not so much not working live at all, but to minimise the live working that we do, and putting control measures in place to ensure that if we have to work live for whatever reason, that we can do so. So in relation to tightening the terminals or checking the tightness of those going to the main switch of an installation, then you know the control measures that one would put in place to check those things would be sufficient. It's a bit like a cable jointer doing the underground cable joint, saying they can't do that anymore when it's live, when they still do, because regulation 14 says we minimise or we mitigate those risks there. So I think the question, and I could be wrong there, was talking about the meter towers coming into the main switch of let's say a domestic installation, rather than those of the distributor like the meter or the service head. So it asks to check tightness of connections.
Yeah. Okay. We've got a question. Do you need a design qualification to design the larger systems? Now it's a great it's a great question, and this really does sort of lead into something which we'll be covering later on in the year, because you may or may not be aware, but some of the things that have come out of the Hackitt requirement are along the lines of mandatory technical competencies for all different aspects and roles. It just so happens that the electrical industry has already done an awful lot of work, and the electrotechnical assessment specification will be the main document that's used to confirm mandatory technical competence in the electrical installation world. So that will become apparent. So please watch this space. It's a great question, because those things are going to be discussed at much greater detail once we get defined guidance that's coming out and it's being produced at the moment. So please do keep an eye on our social media, because we'll be responding to in that area in the very near future.
It is important to say that 7671, when we talk about designing installation, shall be conducted by one or more skilled person. And when you look at the definition of a skilled person electrically in 7671, it talks about having the appropriate skills, knowledge, experience, training within that type of installation to be able to do that aspect of that job. Yeah.
So it's not, one thing we would say is it's not just qualifications, but there are other areas that need to be evidenced in order for you to confirm that you are that skilled person. Question: EV charge points that have built-in onboard RCDs that don't have a test button, are they compliant? And the engineer that's asked the question has said their opinion is that they are, if they meet the IEC standards and also manufacturers' standards. BS 7671 shouldn't restrict innovation, and there's some commentary to say that they've had that confirmed by the head of the JPEL committee. What's the NIC's EIC's opinion? Quite simply, 7671 does give very clear guidance on what type of RCD is appropriate. So yes, as you've said in your question, so long as they meet the one of the IEC standards, the BSEN standards that's specified in 7671, then that's fine. But they do need to meet that, and just be mindful, because we've seen some documentation that says things like the characteristics of a XYZ RCD or the functionality of an XYZ RCD. So make sure that it says it conforms to the requirements of BSEN 61008, 61009, or one of the list of RCDs which is clearly listed in section 722 for EV charging.
Yeah, it does say they are BSEN product standards, and it is the product standard that generally restricts, at the moment at least, the capabilities of PC board RCDs to act in that regard, or the way that they can be tested, and the set requirements that 61008 and 9 require to meet in relation to the fault currents imposed upon them. So if a manufacturer has an RCD on a PC board that has met all those requirements, they've been tested and they're suitable and do comply, happy days, fantastic. But at the moment, it's not commonplace that PC board RCDs meet the requirements within 608, 9, and I forget the third one, 6493 from memory.
So yeah, it's really it's nice and clear. There's a definitive list in 7671, and providing the RCD complies with the product standard for one of those listed RCDs, then we're happy that it's compliant with the requirements of 7671. There's a couple of questions that we're not really going to get into. Opinions on companies making their engineers do 4 EICRs a day, and also the remedial work for each job. Clearly that's not practical. That's not achievable. The thing that I would say there is that one of our industry colleagues, the Electrical Safety First, fairly recently, towards the back end of last year, published Best Practice Guide 10. Best Practice Guide 10 freely available to download from the Electrical Safety First website. It's been produced by industry stakeholders, so ourselves, the likes of the IET, BEMA, NAPIT, City and Guilds, so lots of people involved in the electrical installation industry have an input into producing Best Practice Guide 10, and that's specifically there really for a guide to landlords and those working in the private rented sector where we're seeing this. So there's some really good information in Best Practice Guide 10 about limitations and the effect that they have on the overall definitive outcome of the report, and how much that report actually then reflects the true condition of the installation. So I would suggest that people working in that sector get themselves very familiarised with Best Practice Guide 10, because there's some good information in there which they can then refer back to their customers to sort of say, well, it doesn't line up with industry guidance. If you're telling me that you want 4 EICRs done a day, that really does not line up with true industry guidance, and we'd have some real concerns about the quality of the condition reporting, and also the quality of the inspection and testing which was being carried out. And if you've got concerns over the quality of the work that's being carried out, I'm not sure that you can have great faith in the outcome and the belief of the outcome, whether that be satisfactory or unsatisfactory. So yeah, I think we won't delve any further than that, other than to say, do the NIC believe we can do 4 EICRs in a day? No. Someone said minimum bonding is 6 mil. You said 10 mil. 10 mil on a PME installation, 6 mil on a non-PME installation. Apologies if I did say minimum was 10, because yeah, quite rightly you can have 6 mil on a non-PMA. How do you choose what MCB rating is required for a remote SPD? Is it just a case of following manufacturer's guidelines? I was surprised that an SPD only had a 32 amp C-type on a 400 amp 3-phase and neutral board as recommended by the SPD manufacturer. Yes, get guidance from the SPD manufacturer, certainly. Quite often now we're finding that these either are coming inbuilt into the SPD device, they've got their own overcurrent protection. If not, they will need overcurrent protection, but as you say, it will be much lower, because although we're seeing a huge transient voltage, there's not a huge current behind it, so we don't need a large or highly rated overcurrent protective device. So yeah, that would be quite common, something like a 32 amp on an SPD, even though that was on a 400 amp 3-phase and neutral board. But yeah, seek guidance from the SPD manufacturer, because it's one of the things that they'll stipulate is what's the rating of the overcurrent protective device required. So yeah, very persistent, the engineer that wanted our opinion on companies making their engineers do 4 EICRs. So hopefully we've answered that. Just quickly scrolling back through. I think again the engineer that's come up. So risk assessment regarding sockets that are not RCD protected in a non-domestic EICR. Great question that comes up an awful lot. The situations where a risk assessment is acceptable as a means of confirming that RCD protection isn't required, those situations are extremely limited now. So it used to be much wider, but effectively the Brown Book Amendment 2 brought it down to, so if you've got ordinary or uninstructed persons, if you've got children, if you've got disabled people, then you can't use a documented risk assessment. So be very careful where you can. Long story short, the HSE, when we were transitioning to Amendment 2, had a lot of reservations about leaving the option of a risk assessment in, because they felt that it wasn't being used correctly, and often a comment was made to risk assessment which didn't exist. So it was tightened up an awful lot. You really are looking then at areas where effectively you've got skilled or instructed people using the equipment. So it's possible in a workplace, it's possible in places where there are restricted access to those socket outlets. But the thing that we always advise people on the helpline is it shouldn't be down to the contractor solely to be producing that risk assessment. It should be done in collaboration with the customers and the end users, because those are the people that actually know how those socket outlets are going to be used once the installation is finished and the contractor's left. So it shouldn't be something, unless the electrical contractor has got real detailed knowledge of how they're going to be used through his experience in that environment with that company. But generally we always suggest that yes, get involved in producing the risk assessment, but ultimately the risk assessment will be owned by the customer, because they're managing the people who are going to use that socket outlet. You're just going to attach that risk assessment to your installation certificate. So yeah, just be very mindful of that. Anything you'd add with that, Craig?
Yeah, so the whole point of the risk assessment being owned by the people that are utilising that installation is to do with the fact that if their process changes 3 weeks after you finish that installation, and all of a sudden that socket that was supposed to be used for one thing is now in the wrong place and they want to use it for something else, it may be that that risk assessment is now null and void, because the people that are using it are not skilled or instructed, and therefore they then have to look at that and say, well, this risk assessment is no longer viable. We might have to get the contractor back to actually change that so it's got RC protection. It's the ownership on the client to demonstrate to the contractor that that particular socket doesn't warrant an RC because of its use, its utilisation, who is using it, who has access to it, and what it's being used for.
Yeah.
And these are quite rare these days. We do have a lot of installations where a better option is to hardwire equipment rather than have them plugged in. But there are certain situations where a plug and socket outlet is advantageous for the customer, but they have to make sure that risk assessment is in place. And by all means, as Sam said, help them write it so they have an understanding of who are skilled, who are instructed, who are ordinary or unskilled or uninstructed. And then they might look at that and go, actually, we actually don't have anyone that is electrically skilled or instructed that would go in that room. So we actually can't write this risk assessment. You better put it on an RCD. So it's that two-way street that a contractor must have with the client to make sure that risk assessment is suitable and relevant.
Yeah. We'll pick up just some final comments. There's one there that I've got to mention. I interviewed a Sparky who said he could do 10 EICRs a day. Needless to say, he didn't get the job. Well, yeah. Thank you. 10, that I think that is a record. I've not heard a boast like that before, but that's just incredible. Okay. just want to pick up on a last one, and this is something that again comes in quite often. So what should I do when I find that on a TNCS, a PME system, the ZE is much greater than the typical maximum of 0.35 ohms quoted? So first thing to say, Craig, that 0.35, is that a maximum? Is it something that the DNO has to achieve?
It's a recommendation. They're not obliged to achieve that value. Now, I believe the DNOs do have percentages of how many of their installations do achieve this, and I can't remember the percentages off the top of my head, but there is a high percentage of installations that do achieve this, but there are certain situations where they do not. But it's a recommended value. It's not obligated to do it. But what we've got to look at there is 0.35, and the difference between that and maybe 0.5 of an ohm is, does that affect your installation's maximum ZS values of your protected devices? And if the answer to that is no, electrically the installation is still safe, but we would recommend that you advise your customer, so the end user of the installation who owns the equipment or the property of which this is serving, and get them to find out if there's actually a possible issue with the DNO service, or it could be that this particular one is on near the end of a run from a transformer, or it could be that there may well be a genuine issue with the installation. Maybe out in the road that the DNO weren't aware of, they might want to look at repairing, but it's a recommended value. They're not obliged to achieve this value.
Yeah, no, it's really clear, and the 0.35 value is a value given, for example, so designers can use it, because obviously until the supply is actually installed, they won't know what the ZE is. So you can do your designs based on a calculated value in 0.35. It's also, it's worth saying that if it is getting worse, so if you did the original install, or perhaps previously you did an EICR at the location, and you've got evidence that it's getting worse, then the DNO will take more interest, because as the provider of the installation and the earthing system, they've got a duty to maintain that earthing system. So if you can evidence to them that a year ago, 18 months ago, it was 0.35, now it's increasing, then that will be useful information to them, and that will perhaps aid in their investigation of what's going on. But as Craig says, if it doesn't affect the outcome of your installation, so for example, if you've got RCD protection on all circuits, then a slight increase to ZE isn't going to affect your ability to be able to disconnect under earth fault conditions. So make a note of it, but it wouldn't stop you being able to produce your installation certificate confirming that your installation is compliant with 7671, if you can meet the required disconnection times of the protected devices you've installed. Okay, we've rapidly run out of time, and so I don't want to anger people by keeping them longer than we said we would. Thank you very much for those people that have put questions in, and what we will do is we'll capture the ones that we didn't get round to answering, and we'll bring those to the fore when we come back again at the start of next month. Just want to make you aware of a couple of things. So we've got a couple of wire webinars coming up, the first one being next week. That's electrical fundamentals, really a back to basics one, understanding the adiabatic equation. Now this is something that we're delighted to do it, and it's something that we were asked by previous audiences at the webinar, something that people really wanted to do, a bit of a refresher, a bit of an understanding, or perhaps just some people it's sailed past them in the past, so they just want to understand what the adiabatic equation's about, when can I use it, when can't I use it. So that will be really good. And then at the start of March, my colleague Craig will be back again, along with Dan Smith, to talk about the electrotechnical assessment and the importance of supervision and training requirements, which have become more and more important due to requirements in the electrotechnical assessment document. So those will be good. If you're interested in those wire webinars, please log on to the NICEIC website where you can sign up for those webinars. You can actually sign up for all the forthcoming ones in one go, which is really good. And if you go on there, you'll also see we've got something like about 50 previous editions of the wire that you can view back on demand. So really good resource for CPD, really good. Other than that, just want to say thank you very much for participating in this live Q&A session. It's been really good. Monday night live Q&A sessions, first Monday of every month, open to everybody. Hopefully it's been useful. If we haven't had a chance to answer your question tonight, then as I say, we'll use that to start the next session, which will be on the first Monday in March, which the screen tells me is Monday the 4th of March. So please, we'll try and pick it up then. Other than that, thanks very much. Thanks Craig. Brilliant as always, really good to see you. And thanks very much to those in the audience for participating. Some great questions and some good comments as well, which really useful, and also made me smile a little. I'm gonna be thinking of 10 EICRs a day now. You know, it's really interesting.
But I don't think I could drive to 10 of them, let alone actually do any.
Well, that's somebody actually put in the chat that they're called drive-by EICRs, which is, yeah, good comment. Okay, thank you very much.
Wonderful.
And we'll see you again soon. Cheers, Craig.
Take care.